On your screen you can see the graph of a function. We are interested in knowing how steep the graph is at a specific point on the function. Let's draw a dot on a random point. We call this point Q. How steep is the graph at this point? Well, I guess that's the reason why you clicked on this video. The slope of the curve at the dot can be defined by the slope of the tangent of the curve at this point. This is a tangent. It touches the graph of the function at Q. If we know the slope of the tangent, we know the slope of the function at Q. If you know the original function of the graph, we can take the derivative of this function to find out the slope of the tangent. Let's illustrate this with an example. On your screen you can see the graph of the function fx equals 2x. What is the slope of this function at x equals 2? There is a formula for finding these types of derivatives. This is called the power rule. When fx equals x raised to the power of a, the derivative of fx, which is denoted as f prime x, equals ax raised to the power a minus 1. So x is multiplied by the power of the original function and then the power is reduced by 1. Now we're going to apply this rule to our function f of x equals 2x. Notice that x is actually raised to the power of 1. Therefore, applying the power rule gives us f prime of x equals 1 times 2x raised to the power 1 minus 1, which equals 2. So for every point along our function, the slope is 2. This also means that at x equals 2, the slope of the function is 2. Remember that if the example had been 2x raised to the power of 2 instead of 2x, the answer would have been 4x. This means that the slope would have been different for different values of x. Now we're going to find some more derivatives using the power rule. The power rule is now on your screen again. The first example is f of x equals x raised to the power of 4. Applying the power rule gives us f prime of x equals 4 times x raised to the power of 4 minus 1, which equals 4x raised to the power of 3. So x is multiplied by the power of 4 of the original function, and then the power of 4 is reduced by 1 to 3. The next example is 8x raised to the power of 10. Applying the power rule gives us f prime of x equals 10 times 8x raised to the power of 10 minus 1, which equals 80x raised to the power of 9. So 8x is multiplied by the power of 10 of the original function, and then the power of 10 is reduced by 1 to 9. Let's make it a bit more difficult now. We now have the square root of x. Do you know how to use the power rule to find the derivative of the square root of x? I'll give you a couple seconds to come up with an answer now, and you can pause the video if you need more time. The square root of x is the same as x raised to the power of 0.5. Applying the power rule now gives us 0.5 times x raised to the power of 0.5 minus 1. This is the same as 0.5x raised to the power of negative 0.5. Our next example is 3 divided by x raised to the power of 2. I'll give you a couple of seconds to come up with the answer now, and you can pause the video if you need more time. Dividing by x raised to the power of 2 is the same as multiplying by x raised to the power of negative 2. This means that 3 divided by x raised to the power of 2 equals 3 times x raised to the power of negative 2. Applying the power rule from here gives us minus 2 times 3x raised to the power of minus 2 minus 1. This is the same as minus 6x raised to the power of minus 3. That brings us to the end of the video. If this video was helpful, I would really appreciate it if you could like this video and subscribe to my channel. If you want to help me out even more, check the link in the description. See you in my next video.